Today's lesson is on bird senses and bird intelligence. I'm going to leave the PowerPoint to the instruction on the sensory perception of birds. And just this video here, I'll talk about some aspects of bird intelligence that I think you might find interesting. There will also be some YouTube videos that other folks have produced that you'll find interesting. So the first basically story that I want to tell you about bird intelligence has to do with the American crow. And you know what a crow is, certainly. There's lots of crows around. And I'm up here on at the bog here in Spruce Flats at the top of Laurel Mountain, Lynn Run State Park. And this is where I frequently see crows and ravens. Now, crows and ravens are both in the corvid family. They're related. And they're also really well known to be quite intelligent. Blue jays also are in the corvid family, so blue jays are intelligent too. When it comes to crows, one of the things that they're very intelligent about is family interactions, social interactions. They live in large family groups. And then they have neighbors. They've got, they live on territories, and there's neighboring families that live in adjacent territories. So they have to be able to identify one another and to remember their interactions from previous fights or escapades or whatever. And then, of course, they have to be able to predict the behavior and figure out who's going to be cooperative and who's not. So they have these social interactions, and that requires a lot of brain power. That's one reason why humans are intelligent in this aspect. We're a very social species. So imagine this. This is a colleague of mine out in Seattle, Washington, who studies crows. And he would just in the general course of his research, he'd have to go and mark the crows with leg bands so that he can identify the individual birds. I just heard a crow, by the way. Maybe it'll show up. I hope it does. So he's got these leg bands, and the best way to catch a crow is when it's still young and in the nest, because these crows are very intelligent and they're not going to let you get very close to them to trap them. So my colleague climbs up into these trees where the crow nests are, and so he's able to access the chicks before they leave the nest, and he can put the markings on, and then when they sort of mature and leave, then he can keep track of them. Okay, so he drives around in a SUV vehicle with a ladder on the top of his vehicle. And the crows all throughout this whole neighborhood where he was working, they would recognize his vehicle, particularly with the ladder. So he started to think, well, they can recognize the vehicle, or maybe it's just the ladder. So he took the ladder off and just drove around in his vehicle. And they basically, you can tell a crow when it's upset. It starts to caw and make lots of noise, and then of course they can swoop down and be aggressive towards you. Well, they would continue to do that even without the ladder on the car. So they recognized his car. So then he turned that into an actual formal study of whether crows could recognize him, his personal face and body. And the way he did this, he worked at the University of Washington campus in Seattle, and they had nests there. And so what happened is he put on a mask, not a COVID-19 mask, but a Halloween mask. And this research was being conducted back in the day when George W. Bush was president and Dick Cheney was vice president. And Halloween costumes, even now, I guess you can get masks of, President Trump or whatever, other politicians. Well, it was popular to go around with Dick Cheney masks, of all things. So he bought a Dick Cheney mask, and he wore that mask while he climbed up to the nests and banded the crow chicks. All right, so the parents, of course, are watching all this, and they are paying attention to his mask. And he did that this many times. There was control masks, and I haven't really taught you the experimental method yet with control groups, experimental groups, but you probably have the idea already. So then he'd have some other folks who didn't band the crows regularly walk around in the Dick Cheney mask, and it would just be on campus somewhere, not even close to a nest, and that person would get mobbed by the crows simply because they were wearing the mask. So the crows were recognizing the masked individual as a source of danger, and they were cueing in on the characteristics of the face. So that's a really great illustration of the crows are very conscious of their environment. They can recognize features, and they're very, it's not even the whole person, it's just, very individualized pieces of an individual. Now, a very short story about continuing on crows is the fact that they again have these social relationships, and they're very complex, just like you and I. I might hold the door open for you as you're walking through the building. I don't even know you, you're not part of my family, I should say. So it's not a close relationship that I have with you, but yet I open the door for you. And that's called altruism, and it's more technically, it's reciprocal altruism, because I'm opening the door for you because probably in another situation you would open the door for me, and it just works better when we reciprocate these good deeds. Well, crows have the same sense of reciprocal altruism. And so you can get some adult crows used to coming in and eating peanuts, because they really like to eat peanuts. You can, set them here. I'm on this deck here. You can set them on the railing and have them come in and eat the peanuts. And you don't even have to be around. You can just put the peanuts there. In fact, this is what happens. There's multiple instances of this. People putting out food for the crows, and then going away, and then finding, an hour later, after the crows have arrived and picked up the food, they go and they find that the food is missing, and in the place of the peanuts, the crows have placed a gift, a little trinket, a little sprig of moss or a flower, or something like that, some object that has no particular food value. It's just that the crows want to thank you for the food. So I'm going to be leaving the bog here and just walking into the woods a little bit, where instead of a crow, I might find a chickadee. I heard a black-capped chickadee here earlier, and you're already familiar due to lesson 1, I believe, between the distinction between black-capped chickadees and Carolina chickadees. Well, chickadees, both species, plus tufted titmice and a few other related species, they are called parids. They're in the parid family, and sort of embarrassingly, they are known as the tits. And so you go to Europe, and there's species like the great tit, the coal tit, the willow tit, and we have a species here in North America called the titmouse. That's our only tit species that has the word tit in it. So, that's just what it's named. I didn't name it, so don't blame me. Well, anyway, all of these tit species, or parid species, they are also thought to be quite intelligent. And in this case, they are social. They do live in smaller groups than crows do. But in this case, they are intelligent because they have great memories. Now, why would they need such a great big memory? Well, it's because they are year-round residents and they eat seeds and insects as well. Well, in the wintertime, there aren't that many insects, so they have to rely on seeds. And in the wintertime, there really aren't that many seeds either. It's pretty much the end of May when I'm making this video, and you can see up here on the top of the mountain, it's barely spring already. So there's a long season over which they have limited food sources. And so they have to store the seeds. They have to cache the seeds, as it's called. And these birds will cache the seeds in anywhere they can sort of lodge a seed. Now here's a tree trunk, and you know, the bird would probably spend some time trying to shove a little seed right in here between the pieces of bark on this tree. And then, of course, the bird then flies into the forest and looks for more seeds. Well, how is it going to remember where that seed is? Not only you got to find the tree, but then you've got to find the particular spot on the tree where you stored the seed. So these birds have to remember, and that's why they have really big hippocampus. Now, I'm telling you about chickadees here, but I'm also looking at black and white warblers. I'm going to stop my video and get you a view of that. There's a black and white warbler right there. Oops. Where'd he go? He's still up there. Middle of the screen. You know, black and white warblers are not a member of the parrot family, but they do share some characteristics with chickadees. Their coloration's a little similar, but they do poke around and amongst the trees, and particularly on the tree bark. Okay, I have to confess to you that I saw two birds. One was the black and white warbler, and the other one was a chestnut-sided warbler. And so I thought the black and white warbler was pretty cool because it pokes around on tree trunks just like chickadees do, looking for little bits of food there. It turns out, though, the video footage that I made, that was of the chestnut-sided warbler. Dr. Callum should check his binoculars first before making a video. Back to the chickadee with really big memory to remember where it stored all of its seeds. As a graduate student back in the 1990s and early 2000s, I worked with Jeff Lucas at Purdue University, and he studied the mental abilities of Carolina chickadees, and he would catch the chickadees, bring them indoors into a indoor aviary. They would fly around, and they would be given sunflower seeds, one at a time, by a computerized food delivery system. And the birds would be, they'd be sort of hungry. It would be timed on a regular basis, and the seed would be delivered on a regular basis. The birds would get used to this system and retrieve one seed from the feeder, and they would store it in a fake tree. All right. In an indoor aviary, you can't exactly have, giant tree trunks like the one behind me, but Dr. Lucas had made up these fake trees, and they all had little hiding spots in them with an infrared sensor that talked to a computer. So every time the bird would perch and stuff a seed into a little slot, it would tell the computer that the bird has stored that seed. So Dr. Lucas then would be able to manipulate these birds into storing a lot of seeds or few seeds. Now, if food is abundant, you don't have to store many seeds. So he'd have some groups of chickadees that would just have as much seed as they wanted to. and they didn't store that many seeds. He'd have other groups of chickadees when he'd take them into the aviary, and he would restrict their diet, at least not in terms of quantity, but rather sort of the predictability. Some days they'd get a lot of seeds, some days they'd get very few seeds, and the birds would never know which day was which. And so to protect themselves from food scarcity, because they didn't know whether today would be a scarce day or an abundant day, they would start to store a lot of seeds. So you see, they never really went hungry because they learned to store seeds for those days when there weren't many being delivered by the computer. Well, sort of regretfully might be the word, because Dr. Lucas would have to sacrifice these birds so that he could look at their brains. Because the birds that were exposed to a regular, predictable environment with abundant seeds, they didn't cache that many seeds, and he wanted to look and see whether their hippocampus had changed size compared to those birds that were exposed to the sort of unpredictable environment. Those birds that stored a lot of seeds, did their hippocampus change size relative to the control group? And so again, you got these two groups of birds, one with a predictable delivery of seeds, one with an unpredictable. And the ones that were living under the unpredictable conditions, they stored a lot of seeds. The question is, did their brain grow? Did their hippocampus, that's required for memory, did it actually increase in size and connections to facilitate the remembering of where all these seeds were stored? So, so with a small little bird, the easiest way, the more sure way of looking at hippocampus size is to sacrifice the bird and study its brain and make measurements directly on the brain. So that's what Dr. Lucas did. At that time, I didn't think that was a good thing to do. I mean, it's an ethical dilemma. Do you want to study these birds and answer this question? And if so, you've got to euthanize them and study their brains. So it's just a question. You and I might make a different decision. But anyway, just to finish up the story, indeed, the birds that had to sort of have better memories, remembering where the seeds were, they did have bigger hippocampus in their brain. So the hippocampus is, if you've got a really big hippocampus, it means you've got a really big memory, and in some aspects, that means you're quite intelligent. So I have in the middle of the screen, it's partially obscured, but this is called a veery, and it is a type of thrush. So it's related to a robin, an American robin. So again, the name of the bird is veery. I'll get a little closer if I can. So a veery, just like a lot of songbirds, has a very interesting call. And that's another sort of characteristic of avian intelligence, and that is the singing ability of these birds. There he goes. And in order to sing, a bird is taught by its father how to sing. Something that you need to know, we'll get to this in a later lecture, but only male birds sing. And the male birds, because it's based on testosterone mostly, and the male birds learn their song from their dads. Now there's a period of crystallization where the little baby bird has to hear the male song and have it written into the brain, so that bird, as it grows up, can sing the species song. Now, adult birds can modify their songs too. There's actually dialects and accents. So a Veery from Pennsylvania might sound a little different than a Veery from New York State. Obviously there's going to be some individual differences too. Now there's also birds that are known to mimic sounds and to have quite a large repertoire of singing ability. The northern mockingbird would be a great example. Also, we have gray catbirds, quite common in the forests of Pennsylvania, and they have very complex songs that they learn, not just from their parents, but also from other species. Well, the capacity to learn and then control the structures in the voice box and trachea to produce those sounds, that takes a lot of muscular coordination, and neuromuscular coordination, I should say. And that is also another illustration of bird intelligence. You have to have a really good brain to work those vocal structures, to remember the way to sing, and to integrate a lot of different kinds of information in the bird song. Many birds have singing or vocal communication that is nearly as complex as human speech, and dolphin interactions too. There's a limited number of animal species on the planet that have true languages, and true language is defined as having a vocabulary and having syntax as well, where there's syntactual rules about nouns and verbs and pronouns and adverbs and things like that. We have sentence structure, you and I. Well, it turns out that many bird species also have sentence structure, and they can put one syllable with another, and it means something different in one order versus another order of syllables. So that, again, is bird intelligence.